Hello, and today's learning targets are I can know and memorize my perfect squares and I can solve an equation when a variable is squared. Let's take a look at the examples. A perfect square is the result of multiplying any integer by itself. Let's list the perfect squares through 400. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. Please make sure you can locate the squared button on your calculator. Also, it would be a great idea to make sure you can locate the button that allows you to go to any exponent or any power you would like to find. And if you do not know where this button is, make sure you ask Miss Ratty. Now let's take a look at square roots. We will find the square roots of the following perfect squares. For now, we will only list the positive answers. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. The square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. The square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 15. The square root of 256 is 16. Square root of 289 is 17. The square root of 324 is 18. The square root of 361 is 19. And the square root of 400 is 20. So now, like for example, 20 times 20 equals 400. So that's how we came up with the square root. And this is a perfect square, so that means these numbers divided by 20 equal exactly that same number, like 20. And so we also know that there are negatives that also can be part of the perfect squares and the square roots. Like, for example, for 9, 3 times 3 equals 9, but also negative 3 times negative 3 equals 9. But for now, we only listed the positives here in this list. So I just wanted to make sure and to let you know, to be aware of that negatives also do work here for perfect squares. So now let's look at solving equations with an x squared. So the first example, x squared equals 25. To undo the squared symbol, the opposite of something being squared is to take its square root. So if I take the square root of one side, I also must take the square root of another. And so what happens is when I have something being squared, like this variable x, but I take the square root, the x and the the squared and the square root just cancel each other out, and I'm just left with x. So let me erase this and get this out of the way here, and we'll get back to the example so you get a lot of space to write. So now that I took the square root, I'm just left with x, and the square root of 25 is actually plus and minus 5, because we know 5 times 5 is 25, but also negative 5 times negative 5 is 25. So my two solutions are x equals plus or minus 5. And I can write here this plus and minus, and that means positive 5 and negative 5. Okay, looking at this next example, the square root, x squared equals 36. So again, to undo something being squared, I want to take its square root. When I do that, on the left-hand side, I am just left with x. And on the right-hand side, the square root of 36 is plus and minus 6. And now, it also is a great idea in your calculator to know how to be able to type in the square root of a number. And if you do not know how to do that, we want to make sure that you ask Miss Roddy and that you can find out how to do that. Let's look at the next example. Whoops. Okay, let's look at the next example. There we go. Okay, now I am going to, before I can get to my variable x here, I have to get rid of this 4. So I have to subtract 4 from both sides. When I do that, I'm left with x squared equals 13 minus 4 is 9. And now to undo something being squared, I will take the square root. And again, when I take the square root of something being squared, those two operations are inverse operations and they cancel out. So I'm left with x equals plus or minus 3. And now I'm going to check my answer here. So I'm going to plug 3 back in for x and negative 3 back in for x and solve this equation. So what this looks like is 3 squared plus 4 should equal 13. And this is 9 plus 4 does equal 13. Now I'll use negative 3 and check that answer. And when I check that answer, negative 3 squared is also positive 9, plus 4 does equal 13. So we know that we're correct. All right, let's continue on. And it looks like I skipped one over on the right-hand side, so I'm going to solve that one first, right over here, because it's a little bit simpler. So x squared equals 289. To undo that x being squared, take the square root and get x equals, and do you remember the square root of 289? You got it, it's 17. So x equals plus or minus 17. Okay, let's continue on. Let's get back to this example right here. And I have x squared minus 8 equals 392. So again, let's isolate my x squared, and let's do the opposite of a negative 8 here, and let's add 8 to both sides. And when I do that, I get x squared equals 400. And then to undo the x being squared, we'll take the square root, and x equals plus or minus 20. And again, we can check our answer, so we'll plug in 20 back in for x. And when we do that, we get 20 squared minus 8 equals 392, and negative 20 squared minus 8 equals 392. And 20 squared is 400, minus 8 is 392, so we're good to go on that one. And here, negative 20 minus 8, negative 20 is also positive 400, minus 8 does equal 392. So we're right. Let's take a look at our last example. Now we have a little bit more going on here with this 3x squared is equal to 243. So I don't see anything, adding or subtracting from the x squared, but I do see a 3 being multiplied by it. So we need to figure out how to isolate that x squared and do the inverse operation of 3 being multiplied by x squared. And the inverse operation there would be to divide by 3 to both sides to get rid of that 3 that's in front of the x squared. And then I'm left with, on the left-hand side, x squared is equal to, and 243 divided by 3 is 81. And that turned out really nice because now if I take the square root of both sides, 81 is a perfect square, and the square root of 81 is plus or minus 9. And so that would be our answer here to that last example. Thanks for listening and have a great day. Bye.